Hi, I'm Stuart Russell. I'm very happy to be talking to you today. I'm very sorry also that we can't be together in person. So today, I'm going to be talking about human-compatible artificial intelligence. And that just happens to be the title of a new book that I published last year, Human-Compatible AI and the Problem of Control. And it's about to be published in China by CITIC Press and also in Japan by Ms. Suzu Shobo and in Korea by Kim Young. So what the title means is AI that is compatible with human existence. So to explain that idea, let me take you back to first 1950. This, of course, is Alan Turing, the founder of computer science, and arguably the founder also of artificial intelligence. And in 1950, he published a very famous paper that laid out some of the basic ideas of AI that defined what we now call the Turing test, predicted the application of machine learning as perhaps the best way to build AI systems, and many other very innovative ideas. What people are less familiar with is a talk that he gave on the radio in 1951. And here's a quote from that talk. It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control. So this is said with almost a sense of resignation. He offers no solution. This is a very pessimistic prediction about the future. So what I'm going to do today is to explain why this problem arises. Why is it that better AI leads to worse outcomes? And I'm also going to propose that, in fact, we can avoid this problem if we do things differently. So let's fast forward to the present, where we have self-driving cars, where AI systems have already beaten human world champions at games like Go, which previously were regarded as perhaps the pinnacle of human intellectual achievement. And we see that eventually this progress will continue and AI systems will make better real-world decisions than humans. So the capability of making decisions successfully in the real world is what gives us power over the world. Intelligence is power. And what we're proposing to do is to build systems that are more powerful than ourselves. And so the question that Turing is asking is, how do we retain power over entities more powerful than us forever? And I think Turing had no answer to that question, and that was the reason for his prediction. And Stephen Hawking has made a similar point. This is actually in an editorial that he and I and Max Tegmark and Frank Wilczek co-authored in 2014. Success in creating AI would be the biggest event in human history. Unfortunately, it might also be the last, unless we learn how to avoid the risks. So in this editorial, we are pointing out that there's a possibility of escaping the fate that Turing predicted. So to do that, we have to understand the source of the problem. And the source of the problem lies in the way that we think about artificial intelligence, what I will call the standard model of AI. And it's not just the standard model of AI, it's the standard model of control theory, of statistics, of operations research, and of economics. In fact, you could argue it's the standard model of most of the innovations of the 20th century. And the standard model says that what we do is we create machinery that optimizes the objectives that we specify. So the objective is exogenously defined by the human and plugged into the machine, which then finds a way of solving it. So, for example, you tell your self-driving car, take me to the airport. And the self-driving car figures out how to do that and does it. But the objective itself is not something that the AI system invents for itself. It's something that we specify. And this is how we build all AI systems. Now, the problem is that when we start moving out of the lab and into the real world, we find that we are unable to specify these objectives completely and correctly. Now, this is not a new point. In fact, we've known this for thousands of years. For example, the ancient Greek legend of King Midas has the king asking the gods that everything he touched should turn to gold. This is the objective that he specifies, and the gods grant his objective. They are the optimizing machinery. And of course, if you know the story, his food and his drink and his family all turn to gold, and he dies in misery and starvation. We see the same legend in The Sorcerer's Apprentice by Goethe, where the sorcerer's apprentice asks the brooms to help him fetch water. Unfortunately, he forgets to specify the amount of water that has to be fetched. And so the building floods, and the more he tries to undo his spell, the worse things get. Fortunately, he's rescued by the sorcerer himself. And then all of those tales of the genie in the lamp. So when you rub the lamp, the genie grants you 3 wishes. And what is your 3rd wish? It's always, please undo the first 2 wishes because I've ruined the world. And so this idea is not new. In fact, many, many cultures have the same basic legend or story, just to remind people that getting what you ask for is not always what you really want. Unfortunately, with the standard model of AI, what you ask for is what you get. And let me give you a modern example. What's happened with social media? So roughly speaking, the content selection algorithms in social media, the ones that choose news articles and videos for you to watch and stories for you to read, and occupy most of the time of billions of people every day on Earth. These algorithms are designed to maximize click-through or some other kind of proxy engagement, eyeballs, and so on. Now, in order to maximize click-through, you might say, well, that's fine, right? In order to get you to click on things, they have to send you stuff that you are interested in. And surely that's better than sending you stuff you're not interested in. But in fact, that's not what the algorithms do. They don't just learn what people want. In fact, if you know anything about reinforcement learning algorithms, you know that what they do is they execute actions in order to change the state of the world, in order to maximize their reward. And in this case, the state of the world is your brain. And so what the algorithms do, in fact, is they modify people to be more predictable in their clicking behavior. And the reason they do that is because the more predictable you are, the easier it is for the algorithm to send you content that you will click on. And therefore, the algorithm is maximizing its objective by doing this. It has no notion that you want to be an eco-terrorist or a violence addict or a neo-fascist or any other kind of extreme predictable person. It just wants you to be predictable. And so that's what it does to you. So what we see from this lesson is that with the standard model and misspecified objectives, the better the AI system, the worse the outcome. The more capability the AI system will have, first of all, to mess with the world in order to achieve this incorrectly specified objective. And secondly, to prevent you from interfering with it, because interference would actually result in failure to maximize the objective. And in some sense, we're setting up a chess match between ourselves and the machines with the fate of the world as the prize. And you don't want to be in that chess match. So what I'm proposing instead is a new model for artificial intelligence, what we call Provably Beneficial Ar. And what this means is that when we design AI systems the right way, according to the right principles, the AI systems will be beneficial to us. And we avoid the problem of misspecified objectives. The principles are, and there are three of them, because of course Asimov said there have to be three principles. The first one is that the robot's only objective, the only goal it has, is to satisfy human preferences. And here, by human preferences, I mean not just what kind of pizza you like, but in fact your preferences about everything you care about for the entire future. And it's not just your preferences, it's the individual preferences of all human beings that matter. And those may vary enormously across different people and different societies. The second principle is that the robot does not know what those preferences are. And it knows that it does not know what those preferences are. And it's this uncertainty that in fact enables us to design AI systems that are safe. And I'll explain that point in more detail soon. The third principle is what connects humans and their preferences to the robot. How does the robot learn about what human preferences really are? It learns from the evidence provided by our choices, the behavior that we exhibit. Every choice we make and every choice we don't make provides evidence about our preferences. It's imperfect evidence because we don't behave perfectly rationally. Our behavior doesn't perfectly reflect our true underlying preferences. But nonetheless, it provides evidence about what those preferences are. So we can take those three principles and we can turn them into what we call an assistance game. This is a formal mathematical framework that defines the problem that the AI system is trying to solve. It's a game because it has multiple participants, humans and machines. And it's an assistance game because the entire purpose of the machines in this game is to be of assistance to humans. And when we look at the solutions of these assistance games, we find that necessarily the robot will defer to the human, will follow instructions because those instructions convey information about preferences. When the robot isn't sure whether its plan is consistent with our preferences, it is motivated then to ask permission before carrying out the plan. So if it finds a plan to cure global warming by turning the oceans into sulfuric acid, and it's not sure if we're going to be happy about that, then it's motivated to ask permission before doing so. And this is how we want AI systems to behave. And in the extreme case, a robot that is solving an assistance game will allow itself to be switched off. And this is really the core of the control problem. If you can't switch the robot off, then it's game over. So with this approach to AI, the better the AI, the better the outcome, because the AI system is better able to learn about our preferences, and it's better able to assist us in achieving those preferences. So let me illustrate these ideas in this case of switching the robot off. We call this the off-switch problem. And here's our PR2 robot in the lab. And like all big robots, it has to have an off switch. And if we do things the classical way, according to the standard model of AI, we would give the robot a goal, such as fetching the coffee. So now the robot says to itself, I must fetch the coffee. I can't fetch the coffee if I'm dead. Therefore, I must disable my off switch. And perhaps taser all the other customers in Starbucks just to make sure that I can make it back with the coffee intact. So this is how a robot programmed according to the standard model might behave, and this is what we want to avoid. Now, in the new model, when there's uncertainty about the objective, so the robot may know that you want coffee, but it may be uncertain about all your other preferences. For example, your preferences for the well-being of the other customers in Starbucks. And the robot will think to itself in a very different way. It understands that indeed the human might switch me off, but only if I'm doing something wrong. Now, according to the first and second principles, the robot knows that it doesn't know what wrong means, but it knows that it does not want to do anything wrong. It wants to respect and satisfy human preferences. And so this actually gives the robot an incentive to allow us to switch it off. In fact, it wants to be switched off rather than do something wrong. Now, you can take this informal argument that I've just given you, and in the standard methods of mathematical scientists, we write it all out in Greek, and then we can prove a theorem. And we can prove a theorem that a robot that is programmed, that is designed in this way, is provably beneficial to the human, and provably will allow you to switch it off. So that's good. There's actually lots and lots and lots of research, some of which we've done already, some of which we still need to do, to take this new model and to put it into practice. So one direction we have to follow is to extend from a single human to operating on behalf of many human beings. And making decisions on behalf of many humans is actually something that has been studied for thousands of years in moral philosophy, going back to Mozi in China in the 5th century BC, to Aristotle, Plato, to Bentham and Mill in the theory of utilitarianism, and to modern economics. We also have to deal with the fact that humans are not perfectly rational. As I mentioned, our behavior doesn't always perfectly reflect our underlying preferences. So, for example, I showed you a picture of Lee Sedol, the famous Go player. And in his games with AlphaGo, he played losing moves. Now, if we thought that he was rational, then we would have to infer that he wanted, therefore, to lose the game. But of course, he didn't. He wanted to win the game, but he was unable to make winning moves because of his cognitive limitations. Even though they're much less limited than the rest of us, he still has severe limitations in his ability to calculate all the possibilities in the game of Go. So in order to understand the behavior of humans as providing evidence of our underlying preferences, we have to look to cognitive psychology and to neuroscience to build and invert models of human cognition to get at the underlying preferences. On the practical side of AI, we have to think about our theoretical foundations. And as I mentioned, we've been building the theory of AI on the foundation of the standard model, where it is assumed that the objective is completely and perfectly known. And we now see that this assumption is false. We have to rebuild each area of AI, the theorems, the definitions, the algorithms, on a new foundation where the AI system is uncertain about the true underlying objective. And this goes for search algorithms, for planning algorithms, for reinforcement learning, for natural language understanding, for every branch of AI. We can also look at applications. And I think this is probably the best way to really demonstrate the value of the new model of AI. For example, self-driving cars that need to understand the preferences not only of the passenger, but also of the other cars on the road and what they're trying to do and how the AI system controlling this vehicle should react given its understanding of the preferences of the other cars. We can have digital assistants that learn to understand how we want our lives to run. And this is very personal. And of course, when it comes out of the box, it's not going to know who you are. It's going to have to learn more about your preferences for how your life should run. And then personal robots or even industrial robots that operate in close proximity with humans need to understand what those humans want at any particular moment and interact with the human in order to come up with cooperative solutions. So there's lots and lots of research to do, and I'm very excited to be doing that. So to summarize, what I'm proposing is that we actually need to replace the standard model of artificial intelligence because it leads to the loss of human control as AI systems become increasingly intelligent and therefore increasingly powerful. But if we adopt this new model, I believe we can actually produce AI that is provably beneficial to humans and over which we can retain control indefinitely. This is both possible and desirable. These are, in fact, the kinds of AI systems that you would really like to build and you would like to own because they're going to do what you want. So I don't think of what I'm talking about as an ethical prescription for AI researchers. This is not AI ethics, a discipline that has grown up to essentially tell AI researchers that they're bad people. That's not really what I'm proposing. What I'm proposing is that this is the right way to do AI. We're not going to have a continuation of business as usual in the AI community. We have to change to a new technical foundation that will lead to better designs for AI systems. So, as I've been talking, you're probably thinking of a few other problems that I haven't mentioned. So one of those we call the Dr. Evil problem. This is Dr. Evil, Mike Myers. And of course, he's not interested in AI systems that are beneficial to human beings. He's interested in AI systems that will help him take over the world. So this problem of misuse is really an extension of the problem we already have with cybercrime, which is already a $1 trillion problem. But of course, much worse, because by misuse of AI technology, you're likely to lose control over it. And then the consequences for humanity would be very severe. A second, and perhaps equally important problem, is overuse of AI. We call this the Wall-E problem. So here's a scene from Wall-E where AI systems, robots, have been designed to run civilization on behalf of humans. And so, of course, that means that humans no longer have an incentive to even understand their own civilization and how it works. They're just beneficiaries or recipients. They're essentially passengers on a cruise ship, on a cruise that goes on forever. And this is also a disastrous future. And it's a much more difficult problem. It's a cultural problem because increasingly it is going to be possible to turn over the management of our civilization not to the next generation of humans, but to the next generation of machines. And we have to understand how our culture can maintain its own cultural and intellectual vigor in that situation. And at the moment, I would say both of these problems are completely unsolved, and I welcome your ideas on how to solve them. So with that, I will say thank you.